Hello, dear students. Good afternoon. So just let me know if I am audible and visible to you guys or not. Good afternoon, Chikmagalur students. Good afternoon, Kalaburgi, Vardhan. So can you able to hear my voice? Am I audible, visible? Can you able to see my screen? If everything is clear and if you can able to hear me and see me, just put it in the chat box. Yes, good afternoon. So let me know in the chat box if I am visible and audible to all of you. Okay. Thank you so much. And thank you so much to all of you. Fine. So today, let's start our session. So once again, good afternoon to all of you. So today we are going to discuss the chapter called atomic structure. Okay. So I have taken some previous years NEET and JEE questions for you guys from this lesson. And today we'll solve some questions from this lesson. Okay. So the topics that we are going to cover in this specified topic is Bohr's model of an atom, de Broglie equation, Heisenberg's uncertainty principle, photoelectric effect, quantum numbers, and some rules for filling of electrons. So what are the three rules for filling of electrons? It is Aufbauer's principle, Pauli's exclusion principle, and Hund's rule. Okay. So we'll see some questions based on those three principles or the rules which is being used for filling of electrons. Okay. So let's start from the first. So shall we go with the questions? Are you all ready? So keep a notebook and a pen or pencil with you. So once I give you the question, you guys try to solve that question and try to give me the correct answer in the chat box. We will also discuss here. Got it? Shall we go? Say yes or no. Are you all ready? Shall we go for the first? Students, am I audible? So some of you try to give me some reply in the chat box so that I can understand. JNV students, JNV, Morbi, Badgal, Anandapur, Solapur. Yeah, I'm audible. So we'll start. We'll start from the first question for this session. Okay. So now the first question is to you on the screen. So the question says the number of radial nodes for 3p orbital is. So we have the 3p orbital and we are asked to find out the number of radial nodes for this orbital. Okay. So it is one of the JEE question. Okay, you can take 1 minute to 2 minutes to solve this question. So it is very easy actually. You can get the answer within 15 seconds also for this question. Such an easy question it is. Can anyone try the answer for this question? And let me know the answer in the chat box. How to solve, how to find out the number of radial nodes? We have one formula, right? Can anyone give me that formula in the chat box? The formula for finding out the number of radial nodes? Option C. Very good. Very good, JNB model students. You are correct. And may I know the formula to find out the number of radial nodes for orbitals? Great, great. Option C is the correct answer. But what is the formula? Can you give me the formula? Others also can try. Others also can try. If you know, put it in the chat box. Put it in the chat box. When we mod the students, what is the formula? You guys have given me the correct answer for this question, no? Okay. So let me go for the explanation. Option C is the correct answer. Okay, it is absolutely correct. And you're very great for that. And how to find out that option C is the correct answer? So if we talk about the node is actually the region in which the probability of finding the electron density is zero. Okay, node is a region in which the probability of finding the electron density is zero. Got it? So in that we have two divisions. Node is classified into two. Otherwise, I can say we have two different types of nodes. Okay, one is radial node and the other one is angular node. So node is classified into two. Okay, so one is called as radial nodes. One is called as radial nodes and the other one is called as angular nodes. Got it? So the formula to find out the number of radial nodes for any orbital is n minus L minus 1. Got it? So here n is the principal quantum number, L is the azimuthal quantum number. Okay, so we have four quantum numbers. So the first is principal quantum number and it is denoted by the letter n. And the second one is called as azimuthal quantum number and it is denoted by the letter L. And n minus L minus 1 will give the number of radial nodes for any orbital. Got it? Now to find out the number of angular nodes, we have to use L. It is just L. L is azimuthal quantum number and that denotes the angular node for that given orbital. Okay. But here we are asked to find out only the number of radial nodes. Got it? For 3p orbital. So for 3p orbital, what is the n value? So this is the n value, right? Principal quantum number. It is equal to 3. N is equal to 3. And let me substitute. Let me substitute n value as 3. 3 minus L. What is L? L is the azimuthal quantum number. So what is the azimuthal quantum number for 3p orbital? So to find out the L value, we have if L is equal to 0, it denotes S orbital. If L is equal to 1, then it denotes p orbital. If L is equal to 2, then it denotes d orbital. If L is equal to 3, then it denotes f orbital. So this is the way to find out the orbital, to find out the type of orbital from the L value. Okay. Now here we have p orbital. P orbital means what should be the value of L? It is 1. Got it? So is this clear to all of you? Like how we are finding out the value of L? Any doubt from this? If it is clear, the calculation for L, if it is clear, just give me an answer in the chat box that it is clear or say something. Say give yes kind of reply. If you do not understand also put it in the chat box. I will explain you again. Okay. So is this clear for all? Friends, you can interact. You don't have to worry or you don't have to get scared of saying something or asking something. Okay, feel free to share. Yeah, okay, fine. So, for p orbital, L value should be equal to 1. Okay, so since it is a 3p orbital, I am putting the L value as 1. So, 3 minus 1 minus 1. So, this one is given in the formula. So, what is 3 minus 1 minus 1? It is equal to 1. Okay. So, the number of radial nodes for 3p orbital is equal to 1. Okay. I want to say one more formula. I want to give one more formula for you guys. Yes, Taushia, tell me, you have raised your hand, it seems. Do you have any doubt? Taushia? Tell me, tell me. You want to say something? You want to say something, my dear? Okay, I think she have raised her hand by this mistake. Okay. See, students, if you're having any doubt, just put it in the chat box. Okay. Yeah, what I was saying. Yeah. I want to give one more formula to find out the total number of nodes. The formula to find out the total number of nodes is equal to total number of nodes can be calculated using, okay, n minus 1 formula. Okay, total number of nodes is nothing but the number of radial node and the number of angular node, right? So here number of radial node is n minus L minus 1 and here it is L. If I add both, this minus L and plus L will get cancelled. So L remaining will be n minus 1 only. Got it? So this is the formula to find out the total number of nodes. You will get questions from this also. They will ask you to find out the total number of nodes also. Got it? So here we are learning three formulas, one for radial node, another for angular node, the third one for the total number, finding out the total number of nodes. Got it? N is the principal quantum number, L is the azimuthal quantum number, and I have told you how to find out the azimuthal quantum number at the orbitals also. Okay, accordingly you find out the number and substitute here in the formula and get the nodes value. Clear? So is this question clear for all of you? Shall I go for the next? If it is yes, give me a thumbs up or type yes in the chat box so that I can move on for the next. If you want to ask something or if you have any doubt, put that also in the chat box. We'll solve that. We'll discuss that and solve it. Shall we go for the next question? Yes or no? See, only if you reply, I can understand. Okay, that you have understood or not. If you're not replying, then it is not possible for me to understand, no, whether you have got the point or not. Okay, so let me go for the next question number 2. Question number 2 is the 4 quantum numbers for the electron in the outermost orbital of potassium is. The outermost orbital of potassium is, or potassium R. So we have 4 options. And this question is from the quantum numbers concept again. Okay. So they are asking us to find out the 4 quantum numbers for this potassium. For the electron which is in the outermost orbital. Outermost means the last electron's quantum numbers value they are asking. Okay. And the atomic number is also given to us. It is 90. So how to find out? How to find out the answer? Or has anyone got the answer? Has anyone got the answer? Which is the correct answer? This is the correct answer. Hmm? Has anyone tried and got the answer for this? Which option is correct? Okay, let's try. Okay. So, okay, some of you have got the answer as option B. JNB, Morbi, Chikmagalur, Pratham. So these people have got option B as the correct answer. Okay, let's check whether B is the correct answer or not. Okay. So to approach this question, first you need to write the electronic configuration of potassium. Okay. Since the atomic number is given as 19, the electronic configuration for potassium is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Okay. So this is the electronic configuration for potassium. Okay. And you can see the last electron is present in 4s orbital. So what we are asked to do? We have to find out the 4 quantum numbers for this electron which is present in 4s orbital. Okay. So what we have to do? We have to take the 4s orbital and do all the things. Okay. What is the n value? N is equal to 4. N is equal to 4 is given in option B and in option D. So either one of these options should be the correct answer. Okay. So next I have to go for, next I have to go for the azimuthal quantum number, which is L. So how to find out the L? Just by looking into the orbitals, right? So since this is an s orbital, L value is equal to 0. In the previous question only we have discussed, right? L is equal to 0 for s orbital, 1 for p orbital. So since it is an s orbital, L value is equal to 0. So among option B and D, so L value is equal to 0 is given in option B only. So we can go for that option. Option B is the correct answer. Option B is the correct answer. So we can straight away go for that. If you want to cross check, you can cross check with the magnetic quantum number M and the spin quantum number S also. Okay. So how to find out the value of M from the given L? For a given value of L, M can take values from minus L to plus L. Minus L to plus L. Okay. So since the value of L is 0 here, if I put minus L to plus L as 0, I will get 0 for M, right? So M value is also equal to 0. So M is also equal to 0 for 4s orbital. Okay. And coming to the spin quantum number, it is nothing but we have only one electron. If this is the 4s orbital, then I have only one electron and it is in the positive spin. So it is plus half. It is plus half. So 4, 0, 0 plus half is the quantum number values for the electron which is present in 4s orbital for potassium. Okay. So option D is the correct answer for this question. So you guys are great. Some of you have given me option 4 and all of you have given option 4. All of you who have texted here have given option B as the answer for this question. So, and that is the correct answer. Good. So now let's move for the next question number 3. Okay. So the question is here on the screen. The question says that the relation between Nm means the number of permissible values for magnetic quantum number for a given value of azimuthal quantum number is. So how to find out the magnetic quantum number from the azimuthal quantum number? So we have one formula to find out that. Can anyone give me the formula? So we have that formula in this option, but in a rearranged manner. Can anyone get the answer from the given 4 options? It is just a formula based question. No calculation based. Straight away we can give the answer. Which option is correct? If you have got the answer, you can put it in the chat box. It's straight away formula based. The relationship between azimuthal quantum number and magnetic quantum number. Has anyone got the answer, students? Okay, fine. Option D. JNB Panchavadi has given option D as the correct answer. Very good. That's great and that is the correct answer for this question. Very good. So the relation is actually n is equal to n is nm. Nm I can say magnetic quantum number. Okay. So magnetic quantum number is equal to 2l plus 1. So this is that relation. Okay. So what is 2l from here? 2l is nothing but nm minus 1. And what is the value of L? So you can bring this 2 to the denominator. So it will be nm minus 1 divided by 2. Got it? So ultimately, you need to learn this formula, which is the relationship between magnetic quantum number nm and azimuthal quantum number L. Okay. So magnetic quantum number is equal to 2 into azimuthal quantum number plus 1. So this is the relation which we have to memorize, and from that relation we are getting one relation which is given in one among these options, and that is option 4. Okay. Clear for all of you? Yes or no? Nothing to do with the calculation here. You just need to memorize this formula. So that is the thing here. So now let's go for the fourth question. Maximum number of electrons that can be accommodated in shell with n is equal to 4r. Maximum number of electrons that can be accommodated in shell with n is equal to 4r. So we are provided with the value of n. Okay. And we are asked to find out the maximum number of electrons that can be accommodated. Very good, very good. Yes, yes, yes. Correct. Very good. Option B is the correct answer. But how option B is the correct answer? So what is the concept we have to apply here? What is the concept? Very good, students. What is the concept we need to apply? Nothing to do much with the concept, but it is just a simple formula, right? To find out the maximum number of electrons that can be accommodated in a shell, we have to use 2n square formula. Yeah, very good, very good. JNV Sabarganda students, you want me to explain the third question? Okay, I'll explain. So let me complete this question and then I will come to the previous question. Okay? Have you joined late? Have you joined late? Okay, no problem. I will explain. I will explain once I complete this fourth question. Yeah, very good, students. The formula to find out the answer is 2n square. Okay. So this is the formula you need to memorize here. To find out the maximum number of electrons that a shell can accommodate, it is 2n square. And here n value is equal to 4. N is equal to 4. Yeah. Yeah. So if I substitute n is equal to 4, I will get 2 into 4 square. 4 into 4 is 16. 16 into 2 is 32. So for n is equal to 4, the value is coming out to be 32. So 32 is the correct answer for this question. Great. So have you all noted this? Did you all write down this formula in your notebook? It's very easy, no? 2n square. So since one of you have asked me to repeat the question 3, I am moving forward to that. So listen, which school it is? Yeah, JNV Sabarganda students, just listen. So it is a question basically from quantum number, and we are asked to find out the relationship between magnetic quantum number and the azimuthal quantum number. Okay. So this is the relation. The first thing is the relation which you have studied in your class. Okay. So for a given value of L, the number of permissible values of magnetic quantum number can be calculated using 2L plus 1 formula. And from that, I have rearranged and got the value of L. So I have kept this 2L one side and brought this 1 to the other side. So plus 1 has become minus 1. Okay, 2L is equal to Nm minus 1. And I have brought this 2 to the other side. So since it is in the multiplication with L, If I take it to the other side, it will go to the denominator, right? So at last I am getting L is equal to Nm minus 1 by 2. And it is given in option B. So is that okay? Clear? Okay. Okay, students. So now let's go for question number 5. Okay. Question number 5. Yes. Which of the following sets of quantum numbers is not allowed? Which is not allowed? Can you guys take some time and get me the correct answer for this question? How to find out the unallowed quantum number set? Option C. Why option C? If you are giving me the correct answer, then I will, the next question from my side is, I will ask how. So you should be ready to give the answer for that question also. How option C is the correct answer and why it is the correct answer? And what is the concept behind this? Pratham from JV, the whole one is also giving me option C. Yeah. L is equal to N. Not possible. Very good, Panchavadi students, because N not equal to L. Yes. Yes. Yeah, JNB Mordi, L is equal to N minus 1. It is not only N minus 1. L can take values from 0 to N minus 1. Okay, clear? Is that clear? Can you able to differentiate between your answer and from the one which I gave you? It is not just equal to N minus 1. It is actually from 0 to N minus 1. Are you getting? See, for a given value of L, for N, L can take values from 0 to N minus 1. Okay. Suppose, since all of you guys have given me option C as the correct answer, and in all the options we have N is equal to 3. Okay. So option C is the correct answer actually. So let me take that itself. So if I have N is equal to 3, yeah, if I have N is equal to 3, then the L values can be from 0 to N minus 1. 0 to 3 minus 1 means I can have L as 0, I can have the L value as 1, and I can have the L value as 2. Getting? Jamie Morby, are you getting? So if it is only equal to N minus 1, then the value should only be 2. 3 minus 1, 2. Got it? 0 and 1 you are not including. So it should be 0 to N minus 1. Very good. So N cannot be equal to L, and that is the correct explanation. So L is equal to 3 and N is equal to 3 cannot be possible, and that is not allowed. Very good. I think I can go for the next. Question number 6. Select the correct statements from the following. So it is a NEET question, NEET 2023 question it is. So we have 5 statements. We are asked to find out the correct statements from the given 5 statements. So which among the 5 are correct? So let's go from the first. Okay. So let me start from statement A. Statement A says, atoms of all the elements are composed of 2 fundamental particles. Atoms of all the elements are composed of 2 fundamental particles. So tell me whether it is correct or not. Is this a correct definition for an atom? Great, you guys are doing really great. You know, your options are correct. But give me the answer. Whether why option A is incorrect. Atoms of all the elements are composed of not 2 fundamental particles. It is composed of only 1 fundamental particle. Okay. So that is why statement A is going incorrect. Okay. And next coming to statement B. The mass of the electron is 9.1 into 10 to the power minus 31 kilogram. So that is the constant value. And you might have studied in the tabular column, the mass of the electron value is 9.1 into 10 to the power minus 31 kg, and it is correct. Next, coming to C, all the isotopes of a given elements show same chemical properties. Yes. Suppose if I take the isotopes of carbon, okay, isotope of carbon. So carbon has three isotopes, C612, C613, C614. So what is actually an isotope? Atoms of the same element having same atomic number but different mass number. That is called as an isotope. Okay. So if an atom is having the same atomic number, then the number of electron is same, number of proton is same. So if number of electron and the number of protons are going to be same, then the chemical properties exhibited by those atoms will also be same. Okay. So the chemical properties, physical properties, everything, chemical properties remain same, not physical in all the cases. So some of the chemical properties will be same. If the number of electron is same, chemical property will be same. So that is also correct statement. Okay, same chemical property. Correct. Next, coming to statement D. Protons and electrons are collectively known as nucleons. Is that correct? It is actually incorrect. Why it is incorrect? Protons and electrons are not known as nucleons. Protons and neutrons are called as nucleons. Protons and neutrons are called as nucleons because we have an atom, we have the nucleus inside it. So this is the nucleus, right? So inside the nucleus, what we have? We have neutrons and protons. Okay. And around this nucleus, electron is revolving. Okay. So this neutron and proton, it is collectively called as nucleons. Okay. So statement D is incorrect. Next, coming to last one. According to Dalton's atomic theory regarded the atom as a ultimate particle of matter. Yes. So in that particular theory, we are considering atom as a fundamental particle of matter. So that is also correct. So B, C, and E are the correct statements among these 5, in which option C is the correct answer. Good. So let's go for the next question. Okay. Question number 7. Question number 7. Yeah, again, you have to find out the incorrect set of quantum numbers from the following. Try to find out the answer first. Which option is correct? Which is the incorrect set of quantum number? Try to find out the answer fast. A, B, C, D. Which among these options are correct? Option B. Fantastic. Option B is the correct answer. Why? Why option B is the correct answer? Very good. Very good, Pratham. No zero is given in magnetic quantum number. Yeah. Very good, students. Very good. So, for a given value of n, L can take values from 0 to n minus 1. And this is the formula. Right. And next, coming to m values should be from minus L to plus L. Right? M value should be from minus L to plus L. So here n value is given as 5. If it is 5, 0 to 5 minus 1 means 0, 1, 2, 3, and 5 minus 1 is 4. So these are the 5 values of L. So m values should be minus L to plus L. So for 0, it is minus 0 to plus 0, which is 0. And for 1, minus L to plus L, so means minus 1 to plus 1. So minus 1, 0, and plus 1. And if it is 2, Minus 2 to plus 2. Minus 2, minus 1, 0, plus 1, plus 2 should be there. Okay. But here in the L value, M value, you see, we have minus 2, minus 1, plus 1, plus 2. But the 0 is not given. Okay. If L is equal to 2, if L is equal to 2, we should have 5 values of M, but only 4 are given. So that is the incorrect set of quantum number. That's why option B is the correct answer. Is it clear for all? Is it clear for all of you students? Shall I go for the next? Okay, I'll go for the next question. If you are having any doubt, put it in the chat box. Okay. Next, coming to question number 8. Match list 1 with list 2 and find out the correct answer from the options given below. So what is a list? List 1 is of quantum number and list 2 is talking about the orbital. So how to find out the orbital from the quantum number? So two quantum numbers are enough, right? N and L is enough to find out the orbital and it is given to us and it is very easy. So let me go from A. In A, I have N is equal to 2 and L is equal to 1. Means L is equal to 0 for S orbital, 1 for P orbital, 2 for D and 3 for F. This alone you keep in your mind. Okay. Now find out the answer. Option A. Very good, very good. Very good students. So if N is equal to 2 and L is equal to 1, then it means it is 2P. Right? N is equal to 2 and L is equal to 1. Means it is 2P. L is equal to 1 for P orbital. So it is 2P. So 2P is given in option C. So A goes to 3. A goes to 3. Taushia, are you getting option B as the correct answer? Everybody is getting A. One student is getting option B. Just check. Option B. Why option B? Some of you are getting option B. So I'm explaining you. Just listen, okay? So A goes to 3. It is a 2p orbital. Yeah, very good, Samarkanda students. Very good. B goes to 4. Why? Because it is 3. N is equal to 3 and L is equal to 2. So it is 3D. It is 3D. And here it is 3S. And here it is 2S. So this particular combination is given in option A only. So option A is the correct answer. Okay? Yeah. Very good. Very good, students. Sabarkanda students have given me the explanation. Great. Shall we go for the next? It is question number 9. And it is a question from photoelectric effect, we can say. And the question is, when electromagnetic radiation of wavelength 300 nanometer falls on the surface of a metal, electrons are emitted with the kinetic energy of 1.68 into 10 to the power 5 joules per mole. What is the minimum energy needed to remove an electron from the metal? So, how to find out the minimum energy which is required to remove an electron? So, what is the term? What we are asked to find out? Minimum energy is nothing but we have to find out the work function, which is denoted by W. Students, please mute yourself. Please mute, don't unmute. Please mute yourself. Don't unmute. Okay. Yeah. So we are asked to find out the W naught work function. Okay. And some of the values are given to us. And those values are when electromagnetic radiation of wavelength. Wavelength is given as 300 nanometer. Wavelength. Wavelength means it is denoted by the letter lambda. Kinetic energy value is also given. Okay. Kinetic energy value is also given. Kinetic energy is given. And we have H value, C value, speed of light, and Avogadro number, everything to us in the question. Okay. So from these given values, we have to find out the value of W naught. So how to find out? Some of you are saying option A, some of you are going for option C, some are going for option D, and some are going for option B also. So which one should I take? Which is the correct answer? Okay, let's check. Let's solve and see which is the correct answer. Okay. Now, to find out this W naught, the formula is E energy minus kinetic energy. E minus kinetic energy. Okay, so this is the formula which is used to calculate the W naught. Okay, if you do not know this formula, just take down this formula in your notebook now. Okay. Yeah. So now what we have to do, we have the kinetic energy value in the question, but we don't have energy value. My voice is not audible for Nizaba but students.
Yes, ma'am.
What about others? So other school students, if my voice is audible, just put it in the chat box whether I'm audible or not. Am I audible to others?
Yes, ma'am.
Okay. Okay, fine. Then Nizamabad students have to check. So let me go forward with this. So we are provided with the kinetic energy value in the question, and now we are asked to find out the energy. So if we get the energy value from the given information, we can substitute here in this formula and get the value of W naught. Okay. So what is the formula to find out the energy? So E is equal to Hc by lambda. E is equal to Hc by lambda. So we have the lambda value in the question. H and C values are also given. We can find out the value of E. But we have to find out for 1 mole of electron. Okay. So we have to find out for 1 mole of electron, because in the options, in all the options you see, it is given per mole. Means for 1 mole of electron, we have to find out the answer. So the energy can be calculated using, for 1 mole, it can be calculated using, so for 1 mole of the electron or the species, is electron, right? For 1 mole of the electron, so energy is equal to Hc by lambda into Avogadro number. For 1 mole of any species, you just need to multiply it with the Avogadro number. That's it. And it is also given to us in the question. Just substitute everything. E is equal to H is 6.626 into 10 to the power minus 34 joule second into the value of C is 3 into 10 to the power 8 meter per second divided by lambda value is 300 nanometer. 300 nanometers. So it is 300 into 10 to the power minus 9 meter into Avogadro number. It is 6.022 into 10 to the power 23. Okay. Now, if you solve this, you will get one answer. I'll straight away give you that answer here, and you guys have to multiply and divide, and you should get the answer which I'm giving. Okay, so try this question once you complete the today's class. So you will get the E value as 3.99 into 10 to the power 5 joule per mole. Okay, so this is the value of E. So all of you must try whether you are getting this E value or not. Okay, so this is the E value. So I have E value in my hand, and I also have kinetic energy in the question. Now I can substitute those two values here in this formula, and I can get the answer. Okay, W naught is equal to E value 3.99 into 10 to the power 5 joule per mole minus 1.68 into 10 to the power 5 joules per mole. Okay, 10 to the power 5, they are same. Just you need to subtract. So if you subtract 3.99 and 1.68, you will get the value as 2.31 into 10 to the power 5 joule per mole. So this answer is given in which option? Yeah, very good. Option A is the correct answer. So many of you are giving me all the answers. Some of you are going for A, some for B, C, D. So option A is the correct answer for this question. Okay. So what we are doing? We are just concentrating on the formula which has to be applied for this question to get the answer. Okay. And from that given formula, I am taking the known values and I am going for the unknown terms. So to find out the unknown term, I am going for the formula which has to be applied. Then accordingly, we are solving and getting the value for that and putting that value in the main formula and getting the answer. Got it? So this is how you have to solve. So when you are trying for any question, you just need to aim for it. Okay, you should not forget the aim. You should not simply memorize, you should understand and then study. So what are the steps to be followed? Okay, to find out this, I need this. To find out that, I need that. So accordingly, you have to study. Okay, so I hope this question is clear to all of you. If you want to take down this, you can take it down. Shall I go for the next question? Shall I go for the next question? Yeah, the next question number 10 is, yeah. If the radius of second Bohr orbit of the helium plus ion is 105.8 picometer, what is the radius of third Bohr orbit of lithium 2 plus ion? So, we are provided with two ions. One is helium plus and the other one is lithium 2 plus. The radius of second Bohr orbit of helium is given. The radius of helium plus is given. Okay. And the Bohr's orbit value is also given. Orbit number. It is nothing but n. Orbit is nothing but n. So n value is 2 for helium plus. We are asked to find out the radius R value for the lithium 2 plus. R for lithium 2 plus we have to find out. And the Bohr orbit for lithium 2 plus is 3. N is equal to 3. So how to find out? So what is the relation? So the relationship between R and N for any two different types of ion is R N is directly proportional to N square divided by Z. So this is the formula which we need to apply here. Okay. Okay. Let's check whether which is the correct option. Okay. This is the relation. Now, for lithium 2 plus, N is equal to 3. For lithium 2 plus, this N value is equal to 3 for lithium 2 plus. Okay. And for Helium plus N value is equal to 2. So now what is the relationship? R and N are in directly proportional relationship, but R and Z are in inversely proportional relationship. So Z is nothing but the atomic number. Okay. The atomic number for lithium is 3 and for helium it is equal to 2. Okay. So you just need to keep this also in your mind. So now what is how to write the relation? So R3 of lithium 2 plus is N3 square divided by Z of lithium 2 plus into Z of helium plus divided by N2 of N2 square, N2 square. Since this helium plus is in the denominator, of the denominator goes to the numerator, right? So the N and Z will get reciprocate with each other. Got it? So this is the formula. Now you can substitute. So we are asked to find out R3 of lithium 2 plus, right? This is what we have to find out. Divided by radius of helium is given. It is 105.8 picometer, which is equal to N3. N value is equal to 3. It is 3 square divided by atomic number of lithium is 3 into atomic number of helium is 2 divided by N value for helium is 2. So it is 2 square. Okay. So what is the answer? 3 into 3 is 9 divided by 3, 2 divided by 4. Okay. So you can solve this. We'll get 3 by 2 as the answer. So R3 of lithium 2 plus is equal to, take this 105.8 to the other side. We'll go to the numerator, right? 105.8 into 3 by 2. And if I solve this, I will get 158.7 picometer as the value or the answer for this question. Okay. So which is the correct answer? Which option? Option A is the correct answer for this question. Got it? Yeah. Yes, Kalabugni. Option A is the correct answer for this question. Very good. Is it clear for all of you? So what is the main thing you are getting or grasping from this question? The relation between R, N and Z. Okay. R and radius and the orbit is directly proportional. Radius and the atomic number is inversely proportional. So you just need to apply this formula to solve this question. Clear? So now let me go for the last question for today's session. It is question number 11 and it is from NEET 2021. Okay. So let me read the question. A particular station of All India Radio, New Delhi, broadcast on a frequency of 1368 kilohertz. The wavelength of the electromagnetic radiation emitted by the transmitter is, speed of light is given. So, frequency is given to us. Frequency is given. What is meant by frequency? It is denoted by the letter mu. Mu is given. We are asked to find out the wavelength. The wavelength is denoted by the letter lambda. Okay, and the C value is given. So how to find out the lambda from the mu and C? So what is the formula? So we know that lambda is equal to C by mu. Okay. We know that lambda is equal to C by mu. So this is the formula. This is the relationship between lambda, C and mu. Okay, straight away formula you can substitute. It is equal to C value is 3 into 10 to the power 8 divided by frequency. So while substituting the value of frequency, we have to substitute in terms of hertz, not in terms of kilohertz, because we have the C value with the meter per second, right? So here you have to represent the value in terms of hertz only, because 1 hertz is equal to 1 per second. Okay. but we are provided with kilohertz. So we can convert this kilohertz to hertz. So how to convert? 1368 into 10 to the power 3 hertz. That's all. Okay, 10 to the power 3 hertz. Now if you cancel out and solve this and dividing, we will get 219.3 meter as the value, exact value for this question. So option B is the correct answer. Option B is the correct answer. Okay, so in this question is very crucial, you know. So there is only one small change given among these four options. So in one it is given as 0.2 and one is given as 0.3. But here we can make a mistake. And here also in the unit we can make a mistake in centimeter and meter. If you don't want to make mistakes in this unit, you have to be very careful with the powers of this 10. Okay. So if you're going wrong here, then you might miss the correct answer. Okay. You may get confused with centimeter and meter. Clear? So do first of all check for the unit and then go for the formula and then try the answer, get the correct answer. Clear? Do the calculation and get the correct answer. So I think this is enough for today. And I hope this session is very useful for all of you. And I hope you guys have got at least some concepts from this 1 hour session today. Am I right? Did you guys get any at least one thing from today's session? If it is yes, if you have got at least one single concept in your mind, put it in the chat box. Is the session useful? Okay. Okay then. So, students, thank you so much for listening to today's lecture. So, I'll meet you all in the next session with the new lesson with some other topic. Okay. Thank you so much for attending the chemistry class today. Take care.